Please join me in welcoming Brian Vecchi, who's the Field Chief Technology Officer at Varonis, for his presentation, Hacking the Cloud, Play-by-Play Attack on GitHub, Okta, and Salesforce.
Thank you very much. This is awesome. Thank you all for coming. My name is Brian Vecchi. I'm our field CTO here at Varonis. I've been at Varonis for about 13 years, and I've gotten to do this a few times. This is probably the biggest crowd at RSA that I presented to, so thank you for coming. On my little badge here, it says Brian Vecchi, Varonis, and on the bottom they give me a little ribbon, and it says, I have no idea what I'm doing. So we are in for a journey together today. I want you to know. This is a fun kind of attack scenario that we put together. We have, at Varonis, if you're not familiar with us, we're a data security company. We've been around for a while. We help protect your data. And we have a security research team. They're all over the world, a lot of guys in Israel, some people in the US, and they spend all their time poking at systems and applications, and these days poking at a lot of things in the cloud, trying to find their way in, trying to identify where there are potential vulnerabilities that the people who want to steal your data could use and get access to and steal your stuff. And I'm going to show you the results of some of that research today. Be forewarned, we do not have that much time together today. If I really wanted to go into a huge amount of detail, this might take a little while. So there's going to be stuff that's going to flash up on that screen. You're going to see me magically, because it's recorded, write scripts. You're going to see some screens flash by. I'm going to be providing as much play-by-play as I possibly can. But if you find this interesting and you want to know more, come find us. We'll take you through this scenario in a lot of detail. Where's Killian? Killian's right here. He's the one who helped us put this together, did most of the work. If you want to see it, we'll do it. You want to understand where and how we found this stuff, we're happy to take you through it in more detail. But with that, enough preamble. Let's dive in. Here's a disclaimer. This is all for educational purposes. We're going to have fun today. So what are you going to see? Here's our flight plan. First, I'm going to take you through how an attacker can use some basic reconnaissance, some stuff that all of you could probably do with either 10 minutes in a script or 30 minutes if you really needed to learn Python. I'm going to find some exposed digital secrets, the kinds of things that an attacker might use to exploit your environment or environments. I am then going to get access to an environment, establish persistence, because I'm a very smart bad guy, and I realize if I open up a hole, that hole might be closed, and so I want another way back in. Then I'm going to use these privileges that I have found to pivot to a variety of cloud applications. I'm also going to call out where, again, if we had 3 hours today, I could go to basically your entire cloud environment, but I'm going to hit some of the highlights. This is going to be an all-star game of data that I'm going to go after. And then I'm going to access and then exfiltrate sensitive data. A lot of this stuff towards the end, thank you, Killian, flies by really, really fast. So I'm going to do my best to call out exactly what's happening. But again, if you want to see it in more detail, come find us, and we'll take you through it. But then I want to flip it around. Because it's one thing to say, look at all of the awful things that are almost certainly going to happen to you. Because as a security practitioner, the easiest thing for me to say, and you've heard it probably from everybody here and everybody that you've talked to in security over the last, 20 years, it's not a matter of if, but when. You're going to have some sort of exploited, some sort of hole exploited at some point. So how could you detect and prevent this? In theory, what kinds of things would you need? What parts of your thinking maybe do you want to change about your preventive controls and your detective controls so that you could detect and resolve things as quickly as possible? Because what's our goal? We talk about outcomes a lot. And our goal are really two major outcomes. One, we want the data to be protected. Nobody breaks into a bank to steal the pens. Anybody who's getting access to any of the things that I'm going to show you today, they're after data. That's the point. Everything else can be rebuilt. Everything else can be replaced. Data is a different story. So we want our data to be protected. How do we measure that? That's one outcome. And then two, when something does happen, how do we reduce the time it takes to detect it and reduce the time it takes to respond to it? If we can minimize those two numbers, we're doing a really, really good job. So with that, let's start from what the attacker sees. So stick with me, guys. A lot of stuff's going to fly by. I'm going to call things out as I can. You're probably going to have some questions. Jot them down. I'm going to do my very, very best to save time at the end so we can do a little Q&A, and you can ask me questions that I get to say, you know what, I don't know the answer to that. It's a good question. I'm going to find out for you, though. Okay, the first thing I'm going to do is do some recon. And this says scan for exposed tokens in GitHub. Actually, that's a little, there's already an error here because I'm going to scan a couple of cloud environments. I wrote a little script here that's going to go out and do some regular expression scanning. The first thing that I'm going to do is look for public Salesforce data. Turns out there's nothing. We have a really good Salesforce team, but I went to a GitHub environment and I found an exposed token. I built a regular expression that looked for an exposed token. I went and scanned through a domain looking for GitHub repositories, and lo and behold, what did I find? Our DevOps team was a little bit sloppy. And they've got a JSON file here that has a token in it. For those of you that don't know what a token is, it's basically a key. It's an authentication key that maps to an account and gives a set of privileges. So I found this token. I'm just going to copy it. And now I'm going to go into a tool called Postman, which lets me use APIs. Because the best way to do this, I'm exploiting a hole in DevOps. I'm going to do some DevOps myself. Why do this manually when I can do this through a tool? So I took the authorization token and I took the ID, and I'm going to pop it into Postman here. So now what I'm doing is I'm using Postman as a tool to use APIs. So now I can use Postman, and a lot of what you're going to see is in this tool here. You can go get it, use it yourself. This lets me use a variety of public APIs to connect into a variety of systems that can be accessed by the internet. Because the great thing about the cloud is that it's just somebody else's internet-connected computer. So I used this token, and what I'm going to do now is get the details of the account that is associated with this token. So what's interesting here is that this is an active account. Sloppy DevOps team. They left an API token, an authentication token, in a public repository that is with an active account. I see the ID associated with that account. So now I want to find out the roles that are associated with this ID. Now, thankfully, all of our developers practice security first, and they would never, ever, ever, ever use an ID in an authentication token that did not practice least privilege. There is absolutely no way that this ID has access to anything but what is particularly needed for the use of this API key. But let's verify that. I'm a very conscientious attacker. I'm doing a pen test for this customer, basically. So what I'm going to do is I'm going to take this ID, I'm going to pop it in, and I'm going to go to their Okta environment and see what this ID has access to. Let's list out the role assignments of this ID that is associated with this authentication token. And lo and behold, again, we assume least privilege. We assume nothing bad could possibly happen from this being exposed. Click send. What do I get? Oh, it's a super admin. Well, that's a bummer for our target, for our victim. Now, some of you might say, well, this is ridiculous. Who would ever expose a super admin? I'd say, well, have you guys ever been a developer? Is there anybody who's ever used administrative credentials when setting up an application and forgotten to take them away? We do risk assessments just in on-premises Active Directory. The number of times we find service accounts that are also administrators is basically close to 100% everywhere we look. So in this case, that's what I found. Went out to GitHub, found an authentication token. So now I have got an ID and an authentication into Okta that gives me super admin. Now, here's where I'm playing a bit of a shortcut. Some of you might be saying, yeah, but it's a super admin. There are other ways for me to go from another Okta user to a super admin, but we only have a limited amount of time today. So I'm going to skip some of those steps. Now I've got a user who is a super admin. What am I going to do with this? Well, I could just take this super admin and go do everything else that I'm going to show you, but I'm a little bit smarter than that because I'm going to assume that our victim here is maybe monitoring their super admin accounts and might see their super admins start accessing a lot of data. I know for a fact they probably aren't because I know for a fact how little data monitoring a lot of organizations do, but just in case, I'm going to establish persistence. I'm going to create a new user so that I can use that user to do all of my nefarious work. So how do I do that? Basically what I'm doing, this is some DevOps code here. What I'm doing is I'm creating a script that's going to go into Okta and create a new user. His name is, I think I have this. His name is David Miller. I'm creating a little email, and I'm creating a password for him. All I'm doing is creating a bog standard user right now. That user could never possibly do any damage at all, yet. So I run this little script, David Miller at Polarize Lab, email, login, password, run it, boom. Now, Okta sends back, I've got an active user, last login, here's when it was created, here's the associated, the name, everything else. So now what am I going to do with this new backdoor user that I've created? Well, I'm going to make this user a super admin too, because now this user can do lots of fun stuff. So I just, again, this is a little script. I say, boom, our user, I'm assigning the role super admin to this user. This is important in Okta because for those of you that use Okta, it's basically Active Directory for your SaaS applications. And my goal here isn't to get access to stuff that's inside Okta, because what data does Okta store? My goal is to use Okta as a gateway into everything else. So now David Miller here is a super admin inside Okta. Wonderful. What are we going to do next? Now I'm going to log into Okta as this backdoor user and start assigning some applications. But, well, I'm going to hold that thought. Let's do this. So here I go. Here's my login. I know my password. I logged into our Okta environment. For those of you that know Okta, of course, it allows you to log in from a web interface, because why wouldn't it? One of the overriding themes about everything that you're going to see here today is that all of these SaaS applications, all of our IaaS, all of our PaaS, when we talk about the cloud, I'm hacking the cloud. The cloud is somebody else's internet-connected computer. I'm going to back up here because this is going faster than I was talking about. So it's everybody else's internet-connected computer, which means everything is built for collaboration, and that is critical here. So let me go again. We're going to log into Okta using this backdoor user. Now, once I log in, I am going to start changing app assignments. Now, Okta allows me access to other applications. So here I go. I'm going to say David Miller, and I'm going to assign some applications: Box, Google, AWS, a few others. What I'm doing now is I'm assigning myself access, but wait, I'm taking a different email address there. I told you this is going to go fast. So what I'm doing here is I am assigning David access to these applications under the context of another user. What does that mean? What that means is now when I log in as David, I can go to any one of these applications. But the problem is David is a person that I made up. So my Box administrator didn't give this fictional David Miller access to anything. In AWS, David Miller doesn't have access to anything. In Salesforce, David doesn't have access to anything, because why would he? I just made him up. Except David's access now isn't David's access. I think his name is Jerome. So what I did is I found a real person, and my super user, who is David, is now accessing all of these applications as Jerome, who is a real person with real business needs and real reasons to have access to a variety of data within these applications, whether they were exposed or configured properly or not. Realistically, I could stop the entire presentation right now, because what I have done is given a backdoor user that doesn't exist. There is no reason for anybody inside our victims organization to do an entitlement review or an access review. Nobody knows who the heck this David Miller person is, but this account now has legitimate access to a variety of applications, and no matter what you do, you're never going to catch it. Well, I won't say that because I'm going to show you how you're going to catch it. But let's see what could potentially be done with this access, and how I might use Jerome's access and the combination of Jerome and David's access to continue to escalate my privileges and get access to data. What might this look like if I were to use this pretty legitimate privilege escalation now to go get access to the target? I say a lot when I meet with folks and talk about security. You know, everybody talks about identity management, everybody talks about perimeter controls, EDR, we've got CASBs, we've got firewalls, we've got all of these controls in all these variety of places, but nobody breaks into a bank to steal the pens. They're after money. I just broke into the bank, but I'm not after pens, and I'm not after money, I'm after data. So how do I get data? Well, what we just saw was the attacker found an open GitHub repo. If you're using GitHub, I'm gonna bet, I'll give you 2-to-1 odds that I can find an open repo. And if you're using GitHub and you've got a DevOps team, they might be using GitHub to store digital secrets. I happen to find an open repo with a digital secret, a single token. A dev was using their own credentials for an integration. I then use those credentials to access Okta. I use those credentials to create a new user. And then I assign that user access to applications through Okta under the credentials of somebody else. OK. And I think I actually used, now that I think about it, I used the credentials of our dev, which is going to be important, because while that person was a dev, maybe he's a business user, maybe he's not, maybe he has access to business data, maybe he doesn't matter, because I know a way to get around it. So the next thing I'm going to do is I'm going to open up all of these applications so that I can use the access and do some additional reconnaissance. Thankfully, these are all cloud applications, which means I can open them up in a web browser, because every cloud application, not only is it somebody else's internet-connected computer. It's all built to be accessed through a web browser and built to be accessed through an API, which makes my job so much easier. So I'm going to click and click and click. I'm going to open up each one of these applications in turn. Don't worry, you don't necessarily need to follow along because I'm going to go through each one in varying levels of detail. I have a bunch of applications open through Okta. And remember, this is the David Miller opening up each application, but each application is assigned to him under Jerome, whatever his name was. OK, so now let's use the access that we have found. What does it mean to use this access? Well, I'm going to start with the easiest one. So I am logging into our first application, which, if you remember, was Box. Box, like OneDrive or Dropbox or Google Workspace, G Drive, is a wonderful way to collaborate. I don't want to go back to the world where I had to VPN into the data center that got access to some SharePoint site, or all my data was stored locally on my machine, and if I lost my machine, I'm up a creek and I can't do my job. These days, everything is in a cloud file store like this. So I logged into Box, and look at this. Jerome's got access to a variety of financial statements. This is the easiest data breach in history, because all I need to do on these is just right-click, create link, I'm done. But file data is incredibly valuable. File data is usually woefully underprotected and unmonitored, so this is easy. All of you are saying, yeah, of course you can do that. What else can you do? Well, I logged into Salesforce, and this, as an attacker, this pisses me off. Pardon me for saying, because I logged into Salesforce, I went through that entire privilege escalation, and I don't have access to any accounts in Salesforce. What kind of irresponsible Salesforce administrative team doesn't just open up everything to everybody? I'm annoyed. So now, but logging into Salesforce without access to any accounts, that doesn't do me any good. Do I have a way around it? Of course I do. I need to get access to some Salesforce accounts. So what am I going to do? Well, what I'm going to do now is I'm going to search for an account. I don't have access to anything, but I do have access to some contacts. Oh, everything is, yeah, I have some access to some contacts, but I can't get access to any of the accounts that are related to these contacts. So what do I need to do? Well, for those of you that are Salesforce experts, I need to modify some settings. And thankfully, Jerome I assigned some admin. What I'm going to do is I'm going to go back to GitHub. In GitHub, I'm going to find private repositories. I'm going to then validate. I'm going to see where all of these entitlements could have been set up, and I'm going to set them up. Because what I want to do now is give myself access to the accounts related to these contacts. And how do I do that? So I go into Salesforce, and what I'm going to do now is I'm going to start modifying user permissions. Yeah, turn off notifications there. So now I'm looking at users. I want to find, here are my admin users, but I'm searching for, there's Jerome, that's me. I am going to go to all users. Who's the user that I'm looking for now? Well, we remember not Jerome, we want, Jerome Boynton, there he is. Now, what I'm going to do is I'm going to edit Jerome's permissions so that Jerome has access to some accounts. How do I do that? Well, I am now going to use misconfigured rights to elevate my permissions. And the reason that I can do this is while our Salesforce team locked down these accounts, they didn't lock down every setting. And the combinations of settings that controls what changes you can make to a user account is a combination of profile settings, system settings, permission sets groups, object permissions, sharing rules, and mute permissions. Yeah, so how many of you go to every single one of those for every single user? The answer is none. So in this case, there are some misconfigured rights that let me do a very specific thing. I'm going to go into system permissions here. Under system permissions, I am now going to go down to, where are you? Scroll, 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 scroll. By the way, if you want to audit your Salesforce settings, you have to literally go to every single one of those for every single permission set, every single profile, every single role, and ensure they are properly set, which of course they never are. Every one of these settings, it's like every rule, every FAA rules from a plane crash. Every single one of these settings comes from some Salesforce feature request, sometimes from 10, 15 years ago. So who knows what they do? So what I've done now is I have given myself the ability to read account data inside Salesforce, or I've given Jerome the ability to read account data. And now it's super effective. You want to see what this looks like? All I did was change one setting, and now I am going to go back. I'm also going to set up the object settings. So now I have the ability to read and exfiltrate and basically not only read data, but export data from Salesforce to basically I can create a report. This is really useful for your Salesforce team to be able to report out of data, because if you've got Salesforce, your CEO and your CFO and your head of sales, they want to see forecasting, they want to see reports, they don't want to go into Salesforce to do it, maybe they'll look at a dashboard, but they want to pull things out into spreadsheets as well. So now, here we go. Let's validate that I can see some accounts. Here are the list of contacts that I had access to, but contacts aren't the data that I really want. What I really want are accounts. Now I click accounts, and I've got access to everything. I've got access to all of the accounts, all of the contacts associated with those accounts, all of the attachments within all of those accounts. Think about, if you use Salesforce, the number of support cases, the number of pricing discussions, the amount of sensitive information associated with each one of these entities. And now I'm going to exfiltrate some of this data, because viewing it through a web browser is one thing. Viewing it in a file that I have stolen and I can go sell is something else entirely. So I'm going to click on one of my accounts here. I'm going to click on a bunch, actually, because I want to get lots of data. I'm going to open these all up in new tabs. And yeah, all of them, yeah, including Vandalay Industries. I love the Seinfeld joke there. OK, now I am going to go down, and I've got related contacts. I can see file attachments. I can see support cases. I can see payment information, because we use our Salesforce as part of our fulfillment. And look at that. I've got credit card numbers, expiration dates, CVVs. If you use Salesforce, I can almost guarantee you this stuff is in there. First question to be asking, actually, this is probably the 9th question to be asking yourselves, is do you know where this kind of data is inside your Salesforce environment? Do you know, just like, do you know where all your digital secrets are in GitHub, and do you know who's mucking about in Okta? So I've created a new, did I save this in a Word document? I did. I saved this in a Word document, but now I've got a file that I can go sell to somebody else. Great. I just got access to Salesforce, further elevated my privileges, got access to sensitive information, saved it to a file. Bob's your uncle. Next, S3. If you use AWS in almost any context, or if you use applications that use AWS on their back end, or if you've got applications that you build yourself that might be using AWS in the back end, you may be using S3 buckets. These are great storage repositories. And of course, they're in the cloud, which means they're in somebody else's internet-connected computer and accessible via APIs. And because they are storage buckets, they often store data. Often that data is highly sensitive. What does this look like? Well, if I want to make an S3 bucket public, I'm going into the Amazon S3 service. Here are all my S3 buckets. I see prod customers. I know this has lots of really valuable information. This is going really quick. So I am going to now block all public access. Amazon, to their credit, a little while ago, made it so that all buckets were not public by default. So that is great, but all I have to do is make a switch, and now this public, everybody can list access, but I don't just want to list. I want to get everything out of it. So what else do I need to do? I am going to edit the bucket policy, and what I'm doing here is I'm making it so that when the public accesses the bucket, they are allowed to get anything out of that bucket. And now I'm copying the URL to the contracts folder inside this bucket, access it from a web browser. Bob's your uncle, there is all of my sensitive data. This is a very small bucket. You can imagine that there might be hundreds of thousands or millions of records, all kinds of data that would be very, very useful, application formatted, but I'll figure that stuff out later. So now I've got access to everything that's in this S3 bucket from any computer in the world. That's great. How many of you know where all of your data is in all of your S3 buckets? And how many of you know which data is highly sensitive? And how many of you know which of your buckets might be misconfigured as public? Because again, not that a developer would ever do this on purpose, but unless they've got security first all the time and are following the philosophy of least privilege, unless you're really doing DevSecOps very, very, very well, and I'm guessing you're not because nobody really is, this may be a problem for you. Okay, now let's download all of these files. I've got the bucket name. Here we go. How easy is it to do this? I copy the bucket. I'm going to go back to my terminal, and I'm just going to run a command that is going to spit all of this out into a couple of documents for me. There we go. Here are my, here's the documents that were in, sort of the data that was inside that S3 bucket. I'm now going to pull everything else down. I've got everything out of this S3 bucket saved locally to my attacker's terminal, my hard drive, wherever I'm doing this from. I could also send it or sync it, and I'm going to do this through another step, sync it to another S3 bucket that only I have access to. That would be another way to do it. But you can see locally here, I've got a folder called, that goes quick. We got to add some more pauses into this, Killian. But yeah, so now I have, and this is a lot of the same kind of data, I have it all saved locally. So to recap, I've gone into Okta and I've accessed box data. I didn't even show you that stuff since that stuff is so table stakes. You know that I can just save those documents. I went into Salesforce, elevated privileges, got access to some data there, saved it to documents. I went into S3, I reconfigured a bucket and then programmatically through an API dumped all of that data locally. What about a database? Right? We're starting to move all of our databases up into the cloud as well. So there's no way that those wouldn't be properly protected. But you see, I'm looking at my AWS configuration screen here. It's my AWS console. There's S3. There's also RDS. So for those of you that are moving databases into the cloud, you might be moving databases into Amazon RDS. That stands for Relational Database Service, I believe. So now I'm going to click on RDS. And basically, I'm going to do the same thing. I'm going to find a database, and I'm going to steal the contents. And I'm going to be even trickier about this. I'm going to take the contents, I'm going to make a snapshot, and I'm going to dump that snapshot into my own S3 bucket. So how do we do that? We go like, oops, let me back up. Oh, no. I may have missed a step here. Yeah, I think there's a video that got cut out here. All right, if you want to see this in more detail, come find us. But the second half of this video, this is my fault. Oh, here we go. We're going to click on the database. We are then going to take an action. We are going to take a snapshot. Here we go. Snapshot of database. We're going to save this snapshot to an S3 bucket. We're going to export this to S3. This is a bucket that I am configuring that only I have access to. Export of database, prod data hosting, everything goes. Now I go back to my own S3 environment, and there you go. There is the, this goes quick. There is our, and I'm setting on this S3 bucket that I just created, I'm setting it up to be publicly accessible with an export role, which means I can connect via an API, dump all the data out just like I did the other way. Here we go. Here is the data. I've got payment methods from our customers. Wow, that's a bummer. That was all stored in an RDS database, which I have now put into an S3 bucket, which I am now going to dump. And what I'm doing here is making sure that I have the proper level of access. There we go. I can encrypt, decrypt. There's my key. But I don't want it to be encrypted or decrypted. I'm just going to blow away that key. Done. Now anybody can access it. I don't need to authenticate to it. And what does this let me do? Gets access to all of my prod data. That's what it's called. You guys have seen this before. I'm basically running the same set of scripts. I'm going into the snapshot, the bucket that stored the snapshot from the database that I just stole, and I'm dumping everything back down to these files. Gotta love the PowerPoint template that is kind of cutting off the bottom there. That's okay, but you can imagine what this looks like. It's the exact same set of commands. And voila, export of snapshot. And now I have stolen all of your database data as well. So, yeah, CD export snapshot. I can send this now to wherever I want, but I've got a local copy of all your data. I can now go sell this on the dark web. I can call you up. If I wanted to now, I can reset all these permissions and I can start encrypting things. We're used to ransomware on-premises file systems. Well, you probably got version history, but I can start really mucking about with your operational environment. Look at this. Here's actually credit card numbers and expiration dates and CVVs. Just view them right from my terminal. I can encrypt it, I can steal it, I can hold it for ransom and say, I'm going to sell this on the dark web if you don't pay me. I'm going to call your local news organization to say that you were just breached. This happened to a hospital that we work with, where before they started working with us, they had data that was encrypted. They had to pay to get it back. As soon as they paid to get it back, they said, yep, but we're going to sell it. So they paid so they wouldn't sell it. And then they paid to not have the breach made public. Thankfully, their friendly local ransomware provider provided a very high quality of service, and this entire thing got done in a couple of days. But the other thing that happened, which was really interesting with this story, is in the initial run-up to them paying, they told their friendly neighborhood ransomware provider, we can't afford to pay what you're asking. And their friendly neighborhood ransomware provider said, we know you're lying because we have access to all of your financial records too. We know you have exactly this much money in your database, or in this financial account. We're not asking for all of it. We're just asking for 90% of it. Just give it to us. Just, you have money, give it to me. Okay, so how do you catch this, right? All of you, you're smart people. You heard RSA. All of you, for any one of those steps, are probably saying, yeah, but, I just went through like 100 different steps. And you can yeah, but your way around a bunch of them, but I can guarantee you that I can yeah, but my way around 3 or 4 different ways to accomplish the exact same thing. So if we are storing lots of really valuable information in lots of somebody else's internet-connected computer that are all built for collaboration, all set up with APIs so that they can connect together, and all have different configuration stacks that are incredibly difficult to secure manually, and we have DevOps teams that are connecting all of these things together, and sometimes, not always, sometimes might have convenience, productivity, or just shipping something at the top of their list rather than security, how on earth can we get our hands around this? Because there are not enough hours of the day, there are not enough people on our team to go and look at every single thing that I just said manually. Even if my own best advice was, take these screenshots, go out to every single one of these applications and look at all of these single settings that I just showed you and make sure that they're set properly, that is not a solution. One of the exercises we do with some of our customers is say, take a picture of your Salesforce configuration screen. Take a picture of your AWS or this bucket configuration screen. Take a screenshot. Come back in a month. Is it the same? Is it different? What changed and why? Even if everything was locked down, doesn't mean that it's going to stay that way. So how do you actually catch all this? Well, the really important thing is to do not just data security posture management, not just posture management, but to combine multiple streams of metadata. So one of the best ways to identify exposure is with context. It's to go find where sensitive information might be, but then combine that with an analysis of the identities, the accounts, the configurations, the entitlements, and where all of that combines to give people access to permissions. But Brian, you say, that is a massive amount of information that is constantly changing. Yeah, it is, which is why this is hard, which is why you haven't done this already, which is why the attackers will always be a couple of steps in front of us, because it's very difficult to go get all of the relevant information, combine it together in an actionable way, let alone build automation on top of it so that you can actually use it. But here's what it looks like if you do. So we can identify exposures because why? Because we look at not only where data is, we look at where it's exposed. We look at the configurations and the permissions and the entitlements that could give someone access to data. For instance, in this case, the repository in GitHub became public. That is a single setting on a single repository. It's sometimes very difficult, especially in big environments, to keep a handle on this stuff. But if you were alerted that a repository became public, or if you did a scan and discovered a public repository, that's a really good step. That's something you should go fix. But then, let's validate the contents of this repository. Not all data stores and containers and repositories are created equal, but if a public repository has a digital secret, like an authentication token, and by the way, there are ways to automatically identify those, finding sensitive data isn't just about PII and credit card numbers and PHI. That's very, very useful, but identifying digital secrets automatically is really important as well, especially when you identify digital secrets that are exposed because they're in a repository that is public. That's step one. So we're going to validate this, aren't we? No, we're just going to say great. Yeah, here we go. And here is the target. We see that it's public, and we see that it has, this is a high priority. And, yep, we're going to go into this repository. We're going to see, there it is, and there is our token. It's just that easy. When you identify the exposure, you can validate that there is nothing that might be exposed. Next. An unexpected user was created via APIs. APIs are incredibly powerful. They are often used for a variety of very, very productive things. Without APIs, none of these cloud applications would be really all of that useful at all. But when you see things like users being created through an API, and then extremely powerful rights like superadmins being assigned to users created through APIs, you have to ask yourself one of two questions. One, are we under attack? Or two, what kind of nincompoop of a developer do we have that's building an automated process to go create superadmins in Okta? Both of these things are things that you should address. So we've got a user that was assigned extremely powerful rights. You know how we know that? Because we saw a user be created. We then saw rights being assigned to that user, and we did an automatic analysis of those rights that it gave access at a superadmin level. This isn't rocket science. It is relatively complicated, but it's not rocket science. If you're gathering the right data, yeah, you can get a really small number of alerts that'll tell you this kind of thing. Then here's where things get a little bit tricky. Impersonation is afoot, because what's happening is, in this case, this is an alert that's saying an Okta application was assigned with a different email than the user's email. This is another thing that would be highly unlikely to be happening during an automatic process through an API, which is what an API is designed to do. Why would we have an application interface to a system that is creating users, assigning elevated privileges, and then doing impersonation assignments? Either somebody has the most spaghetti of spaghetti code, and we need to address something, or an attack is afoot, because there's really no other reason for this to happen. If there is, tell us. And if there is, at least you know about it. Okay, so, yep. And if I want to see the specific details here, I should be able to, right? So I'm going to click on this. I'm going to show the activities. Here are the specific events that are related to this alert. In this case, it was a single event. Inside this, I'm going to click on the log. What do I see? Yep, here it is. I've got this user who is performing the action, but then the subject of the action is this user here. So this is how we discovered this. This is a single event that contains two different users, and we know that it's an application assignment. So we're analyzing the event, we're analyzing what is actually happening, and we're analyzing the contents of that event through a lens of, why is this strange? But then our attacker is doing some recon. So remember David Miller here? He is connected to an unusual amount of applications in a short time span. You know that video that you saw where he went click, 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 and all those things opened up? It is rare that somebody does that, unless they have their browser default, like I do, set to open every application that they have access to as soon as their computer reboots. Maybe that's what's happening. Maybe that's not what's happening. So David here connected to an unusual amount of applications in a short time span. Let's see what these activities are. What's also really important here is logs are useful. You can't catch what you can't see, but context is really useful too. So make it so that we're not looking at unrelated events here. I don't want to see all of the noise. I just want to see the stuff that is relevant to what I'm investigating. Remember, one of our goals is not just to reduce the time it takes to detect a threat, it is to reduce the time it takes to investigate and respond and recover from a threat. This is a really good, this is an example of what that actually looks like in practice. If I can easily filter out noise, my time spending investigating this goes down, which is our goal. So here is one of the events related to this attack. I'm going to open this up, and you see, yep, David here is accessing an application, and he is accessing it under the context of the other user, which is not surprising, since that's exactly what you just saw me do. But now, as an incident responder, as a threat investigator, as a security analyst, this gives me a lot of really valuable information, and I didn't have to go dig through a bunch of separate application logs to do it. Okay, then we have the privilege escalation. So for some reason, we have a user that is assigning elevated privileges to an application. We also have the excessive object access. So I just stepped through a couple of things in the interest of time. I basically compressed a lot of it, but remember all of those steps that I went through in Salesforce? That was a privilege escalation. It's not a single event that generated that alert. It is a series of events that generated that alert, but that alert is given much, much more context by what happened immediately after it. What happened immediately after it? An excessive amount of object access. So think about the alerts that you get in your SOC or your SIM, or maybe your MSSP gets it. You might see a privilege escalation. You might see an unreasonable geo-hop or an impossible travel. All of those are worth investigating, but you know the ones that you should triage to the top of the list? Is an impossible travel or an unreasonable geo-hop or a privilege escalation that immediately results in a lot of data access. One of the scenarios that I walk through when I show people investigations and I talk about how you can make investigations more actionable is that impossible travel example. How often do your users access your environment from a new location? Maybe they're on a plane all the time. Maybe they're accessing from hotel Wi-Fi or airport Wi-Fi or restaurant Wi-Fi. Maybe they're home this time. Maybe now they're at a public kiosk. Any one of those things on their own might be completely benign, where if you investigate everything, you're going to be chasing ghosts. But any one of those things that also involves a different device or access to data that that person has never looked at, or in this case, an excessive amount of data access, now it's something real. Now we are reducing our time to detection, and we are reducing our time to investigation. Let's see the specific actions here again. Here are the specific data elements that were accessed as part of that data dump. You can see all of our accounts that were accessed, and now we're combining multiple log streams, by the way. This is really important. I was looking at GitHub logs. I was looking at Okta logs. I skipped the Box one. Now we're looking at Salesforce logs. But combining the different metadata streams, not just logs, but the metadata streams, because it's logs, but it's also permissions and exposure. It's also data sensitivity, too, because we know that inside these account data, there was sensitive information, right? We looked at those credit card numbers with the CVVs, with the expiration dates. Those are incredibly valuable. I can get on Amazon right now and start buying stuff. So inside this account was this document. Inside this document was sensitive information. I can see that there was PII and PHI that were in here. I can also see, because I'm combining different kinds of metadata, I can see all the different people who could have access to it. I've also done a normalization of the permissions, so I can see all of these people can read it. So now I know that this data might be relatively exposed, and I can go and see all of that was accessed. Okay, and the exfiltration, of course, didn't end with Salesforce. We moved on, oops, back up. Come on, there we go. We moved on to Amazon S3. I made a bucket public. I downloaded, I exfiltrated that bucket. I also accessed a database, and then I created a new bucket, sent it over to, or I sent the contents of that database to a new bucket, and I downloaded everything. All of those should be alerts that you should be able to investigate and tie these behaviors together. We are at the end here. So let's sum this up. A minor misconfiguration could potentially lead to a disaster. So look at your configurations, look at your posture. Lateral movement is different in the cloud. We often think of lateral movement as server to server, device to device. In the cloud, it's application to application, often through APIs. We need to combine metadata from multiple sources in order to find risk, and if we find it, we can measure it. If we measure it, we can reduce it. That's how you protect data. You measure risk, you reduce that risk, you have metrics behind it, and you reduce the time it takes to detect and respond to a threat. What should you do in the next 6 to 12 months, or the next 6 to 12 hours after you walk out of here? Perform a risk assessment in your cloud environment. That's IaaS, PaaS, and SaaS. Specifically, look at third-party risk and API connections, because those are going to be a gateway for an attacker that knows what they're doing. If you haven't done one, do a purple team, not just in your data center, do it in the cloud. It's easier than you think. I guarantee you it's going to be more eye-opening than you think. And when you do all this well, it's the first time I'm mentioning the word compliance. I don't like talking about compliance for a variety of reasons, but compliance is an outcome of attacking those first two problems. If you measure and reduce risk, and you lower the time it takes to detect and respond to threats, the compliance controls become a byproduct. You are in a much better position to keep data private. But if you look at your environment through the MITRE ATT&CK framework, through NIST, through whatever framework that you want to use, it can often give you a very good starting point. I think I'm at the end of my time. Thank you all very much. I hope this was fun. Come down to our booth. We've got the clawnimation. We have a claw thing. Anyway, my name is Brian. Thank you all so much. Enjoy the rest of RSA. What was that? You got off of Salesforce? Yeah, but move to what? Salesforce is like democracy. It's the worst CRM except for all the others. I know. You can't get off Salesforce. It's too business critical. Thank you. Thank you very much.